Welcome everyone to the new year, new academic year, if I may say, and the new year of JnanaMarga's physics program. We have been doing physics for now almost 2 years, and we have a particular way we teach physics, which is a little different from the way you would learn physics from everyone else. Particularly for the class 11 students. And also for the class 12. Ours is we first teach you the maths behind the physics, which is essential to understanding class 11, class 12 physics. So with the basis built on the maths that you need for the physics, then the physics becomes a lot different and easier. And it is also clearer. This is how it is classically taught. So that's how we also do it. Okay, a typical student who uses our platform also uses our app, and our apps come integrated with the ebook from your school. Okay, so if you are a NEET student, you will be getting the app which is called Sushruta. So, and if you are a JEE student, you will be getting the app which is called Ramanujan. Both the NEET app and the JEE app include physics. We, in addition to the NEET and JEE app, right, we have the app can be downloaded onto your cell phone, and it is used in parallel with the lectures. We also have a more comprehensive program which includes a tablet-based solution, and that is also available to students. You can get the tablet-based solutions, and we buy the books for you. But typically, these are the books that we recommend. They include our the ebooks from NCERT, which come with the app. But on top of that, if you're going to be a JEE student, we recommend HC Verma for physics, Tiwani for maths, and you should buy one or two books for chemistry as well. Now, if you are a NEET student, we again recommend HC Verma for physics, and for the NEET student should consider buying the A to Z set of books. For maths, we recommend Tiwani, as I explained, right? So let me get going with today's lecture. Okay, so the maths that you need to study physics begin with two two very specific things that you must learn. Okay, one is calculus. At the outset, I produced this picture. Right, this is a picture of Sir Isaac Newton. Sir Isaac Newton is credited with both the most fundamental laws in physics, notably in mechanics, as well as gravitation, right? As well as the introduction of calculus in a very big way. Between him and Leibniz, they introduced calculus in the study of many things. And then calculus, within a very short period of time, took over and is today essential for anybody who wants to understand physics and also chemistry these days. And calculus is used extensively. It's used in finance, etc. Okay. So now, to understand physics, you must understand this the two fundamental techniques that calculus uses. One is called the derivative. Okay. Now, the derivative, before I come to the derivative, let me introduce a second term. A second idea that you must understand is this idea of quantities in physics. Quantities in physics are understood using scalars and vectors. Okay, so a scalar is a quantity which essentially has only a magnitude. What does magnitude mean? It has a associated with it a number, right? So mass of something, right? You go stand on a weighing scale, you try to find out this term called weight, right? The term called weight is actually a vector. Okay, weight in physics is a vector. They have a quantity related to it called mass. Mass is a scalar, you know. So this you may have already learned. So when you look at your first chapter, you look at, essentially what physics is all about. I will come to the real first chapter in your textbook later, you know, because first you must understand these two notions in physics called vectors and calculus. So what is a vector? We are familiar, most of you will be familiar with this term, right? Vectors have both magnitude and direction, and they are typically represented by writing AB with a line on top with an arrow. So you say A, B, and an arrow on top. So that is a directed line segment where A is the initial point and B is the terminal point. Some vectors are freely moving vectors. Okay, the typically when we say a vector has both magnitude and direction, a vector also has a, a length in terms of the direction. Okay, so you can think of direction in, let us say, in two-dimensional space, right? In two-dimensional space, direction is represented using the letter I along the x-axis and the letter J along the y-axis. So now you can look at any direction. If you had a direction at an angle 30 degrees from the x-axis, so if that angle is 30 degrees, you can introduce a unit vector. What is a unit vector? A unit vector is a vector whose magnitude is 1. Okay, now what is the direction for that unit vector? Okay, if it is at an angle theta, you can say that cos theta I plus sine theta j represents the vector. So it represents the unit vector. So cos theta I plus sine theta j, right, will represent the vector at an angle theta with the x-axis. Very simple idea, right? So what is the magnitude of that vector? The magnitude of that vector is 1, because cos squared theta plus sine squared theta equals 1. Okay, for any theta. Okay, so if you had a 30-degree angle, cos squared 30 plus sine squared 30 equals 1. If you had a 60-degree angle, cos squared 60 plus sine squared 60 equals 1, and so on. Okay, so because it's true for all angles, we say that you have a unit vector, which okay. So now, if you wanted to represent any vector using this, using this, you can say, you can multiply that cos theta I plus sine theta j with the magnitude of that vector. Okay, so let's say I had a plan where I said, somebody is to now located, from the origin at a distance of 5 kilometers. Let us say origin is some place in Ahmedabad. Okay, where maybe center of Gandhinagar, or Motera Stadium, I don't know, so some place in Ahmedabad, I call that as the origin, right? So 5 kilometers from there at an angle 30 degrees, right? So 5 times cos 30i plus sin 30j represents the vector to the new position. Okay. So position is a vector. Okay. Now, so there are different types of vectors. There is a zero vector, there is a unit vector. We just now discussed a unit vector, right? Now, a zero vector is a vector which has no magnitude. Okay, so its initial and the terminal points coincide, so it doesn't matter, so it doesn't have an angle and no magnitude, right? Co-initial vectors are vectors which have the same initial point. Now, two vectors are equal if they have the same magnitude and direction. They do not need to have the same initial point. Okay, so that is very important to note. Okay, now in negative vector, if you have a vector a, minus a represents the negative of the vector. Now a free vector is a vector whose initial point is not specified. A localized vector is a vector drawn parallel to a given vector, but through a specified point known as the initial. Okay. So why do we teach this in such detail first, right? Because vectors are essential to our understanding of physics. The all things are understood as either scalars or vectors. All quantities studied as physical quantities in physics are, at least in class 11, class 12 physics, are essentially understood through the lens of vectors. Okay? So collinear and parallel vectors, two vectors are collinear, right? Remember that if you had two vectors like this, if you see my hand, right? Two vectors like this, one vector like this, one vector like that, they essentially don't fall on the same plane, right? What does it take to specify a plane? If you had 3 points, then you can fix a plane. Okay, if you had 3 points which were not in a straight line, you will get a unique plane. Okay, now two vectors are coplanar. So how do we look at understand that, right? So this is just essentially the idea of how mathematics studies vectors. Now vector addition, right? Now remember, vectors have both magnitude and direction, right? So when you add two vectors, right? So if I had a vector AB, right, and a vector BC in pure geometric terms, the sum of AB and BC is the third leg of the triangle and is AC. Okay, so the vector sum is got. So if I had x1i plus x2j, or x1i plus y1j and x2i plus y2j, the sum of the two vectors will be x1 plus x2i plus y1 plus y2j. Okay, this is a very important point. The I vector and the j vector, they are said to be orthogonal. What does the word orthogonal mean? They are 90 degrees to each other. Okay, if you had a z vector, z is orthogonal to both x and y, right? X, y, z, or x, y, z. Okay, x, y, z. Okay, so x, y, and z are perpendicular to each other, and therefore they are said to be orthogonal vectors. Orthogonal vectors, what happens is that you add the i's, you add the j's, but they do not affect each other in the addition. Okay, you separately add the i's, separately add the j's, and the resultant is the sum of these two. So here, if AB was x1i plus y1j and BC was x2i plus y2j, AC will be x1 plus x2i plus y1 plus y2j. So that is the way vector addition happens. You have commutativity is a property of vector addition. Associativity is also a property of vector addition. Okay. Now, subtraction of vectors is basically the same. Only thing is subtraction is addition with the negative vector. What is the negative of a vector? If I have A as x1i plus y1j, right? Minus A is minus x1i minus y2j. A plus B is merely A minus B is merely A plus minus B. Subtraction is the addition of the inverse of the second vector. Okay. So multiplication of vector by a scalar, that happens all the time. The direction does not change, only the magnitude grows. When you multiply a vector by a scalar, direction does not change, only the magnitude grows. Okay. So now there is also the section formula. Section formula is when you divide, let's say you have let AB be 2 points, right? And C be a point that divides AB internally in the ratio m:n, then the position of C is given by MB plus NA by M plus N. Okay, so you have the origin, you have 2 points, A and B, right? C divides AB with the ratio m:n. So MB plus NA divided by M plus N, the third vector. So you had OA, OB, and OC. What is little a? Little a is OA. Little b is OB. Okay. So if M and N were equal, so if C was the midpoint of AB, then you will end up with A plus B by 2. Okay. Now external division is when you have 2 points and then you have a third point outside. Okay. So now, so this is the proof for the internal division. I won't go into the detail. Okay. So 3 vectors you can test for coplanarity. Okay. So now what do we mean by coplanarity, right? How do you test if 3 points are collinear, right? How do you test if 3 points are collinear, right? We already looked at that, right? 3 points are collinear if there is some way to say that the vector connecting AB, right, and the vector connecting AC, one is a multiple of the other. That is, they have the same direction, right? So A, B, and C, right? Now, if AB and AC have the same direction, right? One is lambda times the other, then you can say that the 2 vectors are collinear. What does collinear mean? They are on the same line, right? Like this. Okay. So that is the idea of collinearity. Okay. So AB equals lambda times BC. Okay. So then there is this idea of coplanarity, right? 3 vectors are coplanar if you take it is very similar to collinearity, right? Coplanarity is collinearity in 2 dimensions, right? So we say that 2 vectors are coplanar if if A1i plus A2j plus A3k, right? B1i plus B2j plus B3k, you take the determinant and the determinant should be 0. This comes directly from mathematics. Okay, so one can be expressed as a, what does this mean in maths? This means that one vector The C can be expressed as lambda times A plus gamma times B. So then you can say that if C can be expressed as lambda times A plus gamma times B, then you can say the two vectors are collinear. If you can do that, then this determinant will also be 0. So if you check for the determinant and you find that it's 0, then you have. So now this is the basis of the ideas dealing with addition and subtraction of vectors. And but in physics, the most important or the first idea that you must learn with respect to vectors is the dot product. Okay, the dot product of two vectors a dot b is mod a mod b cos theta. What is mod a? It is merely the magnitude. Okay, so what is the dot product of a and b? Right, a dot b is a, the magnitude of a times the magnitude of b times the angle, the cos of the angle between the two vectors. What is cos 0? Cos 0 is 1, right? So if two vectors are in the same direction, the dot product, they are parallel vectors, right? The dot product of those two vectors will merely be the product of the magnitude, because the angle between the two vectors is 0 and cos 0 is 1. Okay, so a dot b equals ab when it is merely the product of the magnitudes, right? For instance, if you had force and displacement, work is the dot product of force and displacement. If the force and the displacement happen in the same direction, the work done is merely the magnitude of the force times the magnitude of the displacement. Okay, so that is dot product. Okay, dot product is used extensively in mechanics for most notably work, but also it comes in electricity and magnetism. Okay, so then the next set of ideas, so dot products are also distributive and commutative, and also scalar multiplication works for that. Okay, now one important point is, using the dot product you can find the angle between two vectors. A dot b divided by mod b gives you cos theta, remember, right? So what is a dot b? If you had a and b like this, a1i plus a2j plus a3k, b equals b1i plus b2j plus b3k, a dot b will be a1b1 plus a2b2 plus a3b3. Okay, then you can see the numerator here. And the mod of a, as you know, will be square root of a1 square plus a2 square plus a3 square. Okay, so so the magnitude is what, right? As I already explained, if vector a is a1i plus a2j, the magnitude of the vector is square root of a1 square plus a2 square, right? So you take that out, and then what remains will be a1 by square root of a1 square plus a2 square. A1 by square root of a1 square plus a2 square is what? Cos theta, right? A2 divided by square root of a1 square plus a2 square is sine theta, right? So this is the essentials of vectors you must understand. Okay, the dot product of two vectors is called a scalar product. Okay, because what does it produce? From by taking the dot product of two vectors, you end up with the result is a scalar. Okay, there is another product called the cross product. Okay, the cross product of two vectors produces, instead of producing, does not produce a scalar, it produces another vector. A cross b produces mod a mod b sine theta, that is the magnitude of the new vector, which is perpendicular to the plane of the two vectors A and B. A, B, magnitude of A times magnitude of B times sine of the angle between the two, and the direction is perpendicular. To find the, typically, how do you find the angle of the new vector, right? If you take your hand, your right hand, and first point it towards A, then you sweep. If it's like this, then you sweep, right? Your thumb will then, and you push your thumb to point 90 degrees, your thumb will point towards the cross product, A to B. They have another way of doing this. This is called the cross, like this. You can do it like this, right? Instead of doing instead of doing the sweep, you can do it like this. These two, and there is a angle between the two. Then the third finger will point to the cross product. Okay, so this you must learn. You must learn to do this. You may have to do this in your exam. You may have to understand how to do this also over a period of time and become very good with understanding how these vectors work. Okay, now if you are given a vector like this, right, you must be able to componentize it. What does componentize it mean? So see, any vector, right, can be componentized along any axis, any two perpendicular axes. Okay, so normally you say this is I and this is J, right? A1I plus, so if you had a vector like this, you componentize along X and Y, right? But then you can change your axis to be, if I make this the vector, right, I can make this only the axis. Okay, then I can say this is my X and this is my Y. So that is very, very important to learn, because in many kinds of problems, you can, by choosing the axis, you can simplify the solution. Okay, so vectors is very important to learn. So this is the cross product. Okay, what is the geometrical interpretation of the cross product? A B sine theta is merely the area of the parallelogram, that if you complete the parallelogram between A and B, the area of the parallelogram gives you A cross B, the magnitude of A cross B, and the direction is, of course, perpendicular. I explained it. So it has a magnitude and a direction. You end up with the cross product produces you a vector, right? So this is, there is also this term called scalar triple product. I will come to that next time. Okay, but now I'm going to quickly switch to another set of ideas that are very important in physics. Okay? Those ideas are the ideas that you get from calculus. Okay, so as I explained, Sir Isaac Newton introduced calculus into physics. Okay. He first made some of the basic ideas around calculus, or he was part of that movement which created calculus, and then he also introduced a variety of ideas to introduce calculus and vectors into physics. Okay, and when they wrote the laws associated with physics, they tried to be extremely precise. Okay, they wanted to use their wording in a very precise way. Okay, like, many of you have heard of the Constitution of India, right? The Constitution of India was written by Dr. B.R. Ambedkar, right? Dr. B.R. Ambedkar used very precise language in writing the Constitution of India, because He wanted the Constitution of India to be available for all the citizens of India for many years to come, that it need not be changed, need not be misinterpreted, etc. Very clearly written, precisely written. Rights of peoples, etc., very clearly defined. Similarly, Sir Isaac Newton also, when it came to physics, he wrote the laws very clearly. Okay? But the laws that he wrote, right, also have on their inside them the fact that you have to understand them using vectors and calculus. Okay? There are two important ideas in calculus that, as a new student in physics, you must understand. The first idea in calculus is this idea called the derivative. Okay, I very much encourage you to attend our maths classes taught by Tarun. Okay, Tarun is a good teacher. Okay, you have to attend the maths classes, and in maths they will also teach you derivatives. But we in physics cannot wait till they teach you derivatives in great detail and integration in great detail. We just cannot wait for it. Therefore, we do a crash course in it upfront. Okay, what is, before you understand this term derivative, right? You must first understand that what it means. Okay, if you had a curve, okay, let us say, right, when you look at um, um, when you look at a body, right, a body could move in a curved path, right? Now, when you uh, look at a body moving in a curved path, right, and you want to determine at any point what is the direction it is moving. So let's say I say it's moving in a parabolic path, right? You would have heard of this, or elliptical path, right? You would have heard of this in people would have told you by now, right? That the earth moves around the sun, all the planets move around the sun, right? Now, in what path do they follow? They follow a elliptical path, right? They would have told you also, if you throw a stone, right? You throw a stone, the stone follows a parabolic path, right? So, what do they mean, parabolic path? What is the, let's say I had a parabola like this, right? What is the equation of that parabola? Y equals x square, right? So now the question I have is, if you had a y equals x square equation, at every point in that equation, what is the direction of the, you throw the stone, okay, it is going in a parabolic path, okay, y equals minus x square is a inverted parabola, right? So normally you say it will be a parabola like that, inverted parabola. I throw a stone, it's going to go up, it's going to come down, right? Going to go up and going to come, going to go up, going to come down, right? So now I want to know at every point in the, as I, when I throw the stone, at every point on the curve, I want to know what is the direction of the stone. Okay. Now, this is the essential idea behind the derivative. This is the physical idea behind the derivative, right? So its direction is continuously changing. Initially, it is thrown, let us say, at an angle of 60 degrees, right? But the earth is attracting it, the earth is attracting it, the earth is attracting it till it reaches the its highest point, at which point it is moving in a completely horizontal direction. It was thrown at 60 degrees, but at its highest point it is horizontal, right? It has lost all its velocity, all its vertical velocity. Okay, that component, there is a, as I explained to a vector has two components, right? This component has completely lost all its velocity, and in fact, as it goes down, it is going to regain, it's going to gain more and more velocity in the other direction. Initially it was thrown like this, but it's now coming downwards faster and faster and faster. I'm sure you have seen this. When you throw a stone at the highest point, it has no vertical velocity. Okay. So how do you determine that, right? That is determined at each point. That is determined by what is called as the derivative. Okay, that is the physical. I explained the physical idea, right? You throw a stone at every point, it has the direction of the stone is changing. Okay, and the direction of the stone, the is when we say the direction of the stone, what do we mean? The direction of the velocity of the stone, right? The position has also moved, right? It is position is moving in a parabolic path, right? So at each point it has a new position, right? So to calculate the velocity at each point, right, we calculate the derivative of the position. Okay? So the position of a the position is what? The position is also a vector. Okay, the the velocity. So now the position, let us say I have the position at time t equals 1, t1, right? Then I look at the position at time t equals t2, right? Now the position at t equals t1 was a vector. The position at t equals t2 is another vector. So let us say the I call the position at t1 p1 and the position at t2 p2, right? So op1 op2, right? So op2 minus vector op2 minus vector op1 is called as the displacement. Okay, now the instantaneous rate of displacement is the velocity. Okay, op2 is a vector, op1 is also a vector, op2 minus op1 is a vector. The instantaneous vector, notice what is happening here. Okay, so now let's come to this slide. Okay, here there is this curve. Okay, on this side it looks like this, straight line like this, and this side looks straight line like this. This is the y equals x side, this is the y equals minus x side. So at any point here, right, you can find what is known as the derivative. So let's say you take this point, what is the derivative, right? The derivative is f of x. Let us say this is the value x, okay, x, right? Or the value 2, right? F of 2 plus h minus f of 2 divided by h. So at 0 it is f of 0 plus h minus f of 0 divided by h. So the increment divided by the increment in y divided by the increment in x. Right? This increases a little bit, this increases a little bit. So increment in y divided by the increment in x will give you the derivative. Okay. And at any point, that is the derivative. Delta y by delta x as delta x tends to 0. Okay. Delta y by delta x as delta x tends to 0 will give you the derivative. Okay. It is merely the slope of the curve at that point. Okay. Now, there are some points where the curve may have what is called a discontinuity. Okay. So such points, we generally also note them, and in some cases you cannot specify a value for the derivative, and in some case you can specify the value for the derivative, right? So typically, if a curve is differentiable at a point, we say that it's continuous. That's what he is discussing here. Okay? So now derivatives follow other rules, and you must learn the various rules of derivatives. Okay, so if you take the derivative of x cubed, derivative is given with this, if you have a function f of x, its derivative is f prime of x, said to be f prime of x. So the derivative of this curve, right, f of x equals x, right, is 1. Okay, because for you, the increase in x versus the increase in y is how much, right? You can see y goes up 1, x also goes up 1, right? And it is a constant value, right? So if x grows by 5, y also grows by 5, right? Now, so what can you say from that, right? That means it is 1. Okay. Now, if it was like this, maybe 60-degree curve, right? For every increase in x by 1, right, y goes by 2. So delta y by delta x will be 2, right? But if it was not a straight line, right? Straight lines have a constant derivative through the length of the line. Okay, y equals mx plus c. What is the slope? The fixed slope across for the line, right? M, right? While if you had a curve y equals ax square plus bx plus c, its derivative is 2ax plus b. It is itself a function of x. Okay, so that is the idea of the derivative, is that at any point it gives you the slope of the curve. Okay, so this idea, right? And so you have to learn little more about derivatives. There are rules associated with that. So the derivative of x to the power of n is n times x to the power of n minus 1. Okay, the derivative of sine theta is cos theta, etc. Okay, so you should spend a little time understanding derivatives. Okay, so there are a lot of rules associated with that. Okay, so we will not teach all the details of that right now, but we will go into the idea of velocity. Okay, velocity is the derivative. Okay, we use the term rate. Okay, velocity is the rate of change of position. Okay, velocity, position is what I already explained, is a vector. We just studied vectors. right? Vectors, right? We just studied vectors, right? Velocity is a vector. Okay, it is the rate of change of position. R of t plus delta t minus r of t by delta t. Okay, so if there is a body, it is at p at t and p prime at t plus delta t. So r of t plus delta t. So r of t plus delta t minus r of t divided by delta t, right? In the previous case, when we were studying maths, right, studying it as a quantity, we did not introduce the derivative of a vector, right? The derivative of the position vector is the velocity, and velocity is also a vector. Okay, so so note that so r of t plus delta t minus r of t divided by delta t, as delta t tends to 0, will give you the velocity vector. Okay, so this is the first thing you must understand, that derivatives are essential to the study um, um, uh, of physics. You know, the most fundamental thing that we look at in mechanics is velocity. Then we look at acceleration. Then we look at force. Okay, all these things are understood through the lens of vectors and calculus. Okay, so through the lens of vectors and calculus, we look at physics. Okay, the speed of a car traveling north on a freeway and the speed of a rocket launched into space can both be measured using velocity. Everything is studied using through this lens of calculus and vectors. Okay, the next idea that we will look at is also a second idea. Okay, so this is I will go over derivatives again because we have almost run out of time, right? The second idea that we will look over is this idea called integration. Okay, integration is the inverse of the derivative, differentiation. In integration, what we do is we take this and we sum it up. Okay, so if you have a f of x, right? If you sum up all the values of x, take this value, this value, this value, this value, you sum the values over an area, right? So you break it up into small trapezoids, right? This is a trapezoid, right? Break it up into small trapezoids and you add the area of all those trapezoids, right? You end up with what is called the integral. Okay, and again there are formulas for that. Integral is actually the inverse of the the differentiation, right? So I will go over this in greater detail next time when we go into the calculus side of things. But integral is what you will do when you take the dot product f dot dx, where dx is the displacement, right? You take the scalar dot product f dot dx and you integrate it. So there is a force which is continuously doing work. F dot dx will give you the work done, right? Now, if your velocity is v1, v2, v3, v4, v5, your velocity is a curve, right? The area under the v versus t curve, when you do an integration, will give you the distance traveled if it is in one dimension. Okay, so I will go over those details in the next class. But for now, we are going to wind down this class and move on.